All right, so today we're still in chapter 4, section 8, and we're still writing those sinusoidal functions, but instead of having a graph on an axis that we can easily get values from, now we have a little story and we've got to pull information from that. Okay, so a mass hangs from the end of a spring and rests 174 centimeters above the ground. So that's at rest. Here's the mass at rest with the spring, right? It's not being scrunched up, it's not being stretched down. So let's give ourselves that midline. Okay, so midline is at 174. I'm just going to make a note of that. You pull the mass downward until it is 160 centimeters above the ground. So that's this low point right here. That's 160. Okay, and you start the stopwatch at the exact time you let go of the mass. Now, when you start the stopwatch, that's t equals 0. So let's place our y-axis. Okay, here we are. We've stretched this thing to the bottom. Let's say that this is the y-axis. This is t equals 0. And the x-axis, or the t-axis, I guess, I'm just going to put down here somewhere. So I know this is 160, this is 174. That's what I know so far. The mass oscillates up and down, completing 20 full cycles every minute. So that's giving us a frequency. The frequency is equal to 20 cycles, 20 periods in 1 minute. That means that we have the period. Let's see, the period. Oh, we want t in seconds. So, okay, let's work on this a little bit. Sorry. So because t is measured in, write the equation that models the height above the ground as a function of time in seconds, we need to make one adjustment to this, 20 periods in 60 seconds. What is that? That's 1/3 of a period per second. So the frequency is 1/3. All right. What does that mean? It means that the period is 3. And how does that help me? Well, just like we did in our previous notes, we know that the period is equal to 2 pi over b. So now I can solve for b, multiply b to this side, divide by 3. B is 2 pi over 3. So that's great. Now I know normally I start with the midline and all of that, and you can still do that, but I just wanted to kind of explain the hardest part. I think this is the hardest part. All right. Now we need to get the rest of our values. So we can see on our graph that the midline, which is equal to D, is 174 centimeters. So we've got D. Now we just need A and C. So A is the distance between the midline and a minimum, or the midline and a maximum. So what's 174 minus 160? That's 14 units, right? So A is equal to 14. Okay. And then what about a shift? Now notice this, it doesn't say that we have to use sine or cosine. So if you're given the freedom to choose, you pick the one that is the easiest to figure out, the one that has not been shifted. So I would say, oh, hey, starting on this y-axis is one complete cosine curve. It's a negative cosine curve, but if I want to talk about a phase shift, I would say for a cosine graph, it's c equals 0. What if I did have to do a sine graph? So if I had to do a sine graph, you would need to figure out, well, where's one period of the sine curve? So you could knock it back here, or you could knock it all the way back here. You could say, well, where does this start? Remember, the period is 3, right? So the period is 3. So from here to here would be a total of 3 units. If the period is 3, and we divide by 4 equal parts, it means that each unit, or each point is 3/4 of a unit. So I could say, okay, this is 3/4 over, this is minus 3/4, this is minus another, let's see, this is minus another 3/4, here's minus another 3/4. It's kind of weird with time to go backwards. So how about we start our cosine or our sine curve here if we had to find sine like that. So if I'm going to do a sine curve, or maybe I was told to do a sine curve, to the right 3/4 would be c equals right is minus 3/4. Okay. Let's see. So let's write our equation. We could say, let's see, let's not use y and x because it says use h of t. So h of t, let's go off the cosine, assuming we were allowed to choose the easy one. This is a negative cosine curve, right? So negative cosine means that we have negative 14. Cosine of b was 2 pi over 3. We said the cosine curve is going to get no horizontal shift, t minus 0. Our variables are t and h of t. And then the midline was at 174, so plus 174. Remember, there are multiple correct answers. So if I were doing a sine curve, I could say h of t is equal to, it was a positive sine curve starting here. So I could say 14 sine, same period, so b is still 2 pi over 3, t minus 3/4 plus 174. That should get me to the same place. And again, we could pick different sine curves. It's not wrong to go backwards and say, like we've been shifted to the left 9 pi over 4. That would be okay too. So it's just, there are a lot of possibilities. Okay. What about this next one? A sinusoidal function, T of t, models the average New Orleans temperatures in degrees Fahrenheit as a function of time, t, months after January 1st. According to the model, the highest average temperature of 85, so our max here is 85, occurs about 3 weeks into July, which is t equals 6.7. I'm just marking in this information. The lowest average temperature is 55, so here, 55, hits it there and there. Doesn't tell us when that, oh wait, about half a year earlier. Half a year earlier than the 6.7. So half a year, we're talking about t is 6 months, right? So half a year from 6.7 means that this happens at 0.7. I subtracted 6 months. So 6 months earlier. All right. According to the model, what is the average temperature on the last day of October? T equals 10. So I'm going to get my calculator fired up while we work on writing the equation. All right, so let's take a look at this. We could start with the midline. Let's try to keep this like we did when we didn't have any context. The midline should be the average of the max and the min. So at max plus min divided by 2. So what is this? 130 plus 10. So 140 divided by 2 is 70. So there's D. That's great. And if we know D is 70, then we can also find, I like drawing the midline in, we can also find A. What's the distance between 70 and 85 or 70 and 55? That's 15. So we've got A. What about the period next? I wasn't given any information about a frequency, so I'm going to do, since I have a graph here and I can see one period of a cosine curve, I can figure out what that is. Now, these graphs are symmetric, so if we hit 55 6 months prior to 3 weeks into July, then we're going to hit 6 months after, so this is 12.7. So the period goes from 12.7 to 0.7, which is 12. That makes sense. We're talking about 1 year, 12 months. And remember, that's equal to 2 pi over b. So you need to solve for b. Multiply b over, divide by 12, simplify. B is pi over 6. Okay, and has the cosine graph been shifted? Oh, by the way, this is a cosine graph, right? So I wouldn't bother. We're not going to find both sine and cosine for each one for these. Let's just pick whichever one works. I think when there's context, I think those are the problems I've seen where they let you choose. As long as your equation produces the correct graph, it will be right. All right, so phase shift. This graph has been shifted to the right. Instead of starting at 0.55, it starts at 0.7, so to the right 0.7. And that means that C to go to the right will be minus 0.7. So we got C. And that was our last missing piece. So let's write our equation. So this is, we're supposed to call it T of T. T of T equals, is it positive or negative? This is a cosine curve that starts down, so it's negative 15 cosine of pi over 6, parentheses, x minus 0.7 plus 70. So here's our model. And the question was, what is the average temperature on the last day of October? So what is T of 10? This is where we go to our calculator. And let's type this in. So, okay, we're using a calculator. Now, I know that in some of our earlier chapters we were in degree mode, but our AP exam will be all radians. You don't need to switch modes. So put yourself in radian mode. And we should just be able to type this in. Negative 15 cosine of pi over 6, parentheses, x minus, oh, sorry, not x, 10 minus 0.7. That caused me to catch a mistake here. This is not, x is not the input variable, it's t. That does matter. You can't call something t of t. You can't call something a function of t and then have a different variable, or that definitely complicates things. Anyway, pi over 6 times 10 minus 0.7, close parentheses around that, close parentheses in the cosine, add 70 to that. The average temperature is 67.653 degrees Fahrenheit, approximately. Okay, let's do our last example. This is another classic example. We are very likely to see something like this, just maybe not a Ferris wheel, on our free response again. So a Ferris wheel, I took this from AP Classroom, by the way, so I don't know. A Ferris wheel with a 34-foot diameter rotates at a constant angular speed, taking 50 seconds to complete one full rotation. Okay, so we get, let's talk about frequency. It takes 50 seconds. Remember, it's how many periods per time is frequency. One full rotation is one period in 50 seconds. So that's 1/50th for the frequency. That means that the period is equal to 50, and that's equal to 2 pi over b. So that means that b is equal to 2 pi over 50, multiply b, divide by 50. So b is pi over 25. All right, we got b. What about this, the 34-foot diameter? So from here to here is 34 feet, but don't label anything yet. We need to know this. The lowest position the rider will ever reach is 12 feet off the ground. Oh, and sorry, you probably are writing in the same place I am. Let's move this information down here because I really like on these to draw your vertical axis and your horizontal axis kind of next to the Ferris wheel. So the Ferris wheel is a guide here. The lowest point on the Ferris wheel is, what did it just say? 12 feet above the ground. And now we can use that diameter. The diameter is 34 feet, so add 34 feet to get to the top of the Ferris wheel. So 34 plus 12 is 46 up here. And then we'll be able to find the midline by finding the midline, right? So the midline is 46 plus 12 divided by 2, or just find half the distance, right? This is 17, this is 17. I guess that'd probably be easier. What's 12 plus 17? 29. This comes out to 29 too, though, right? 58 divided by 2. Yes. So lots of ways to find that. I love sketching a little midline across. So there we go. All right. And then let's see. So at time equals 20 seconds, Bill the kitten is at the position indicated at the figure. So not at 0 seconds. Let's put 20 seconds out here. At 20 seconds, Bill is at 29 feet off the ground. Um, and he's traveling in the indicated direction. Write an equation for Bill's height off the ground as a function of time. When will his height, or what is Bill's height at t equals 0? So we're trying to get back to here. All right. Where does Bill go next? From this, Bill goes at the next tick mark. We'll figure out what that is. Bill goes down to 12 feet. At the next tick mark, he goes back to midline. At the next tick mark, he goes up to 46. And at the next tick mark, he lands back where he started. How do I know how far apart these tick marks are? Well, remember, the period is 50. So this one little sine curve here stretches across 50 units. So from 20 out to here should be 70, right? I added 50 to that. And I'm looking at my yeah, sorry. I was looking at my other answer key in it that I think I caught an error on. So anyway, so this happens in 50 seconds, right? So that's 20 seconds, then here's 50. All right, so yeah, it takes 50 seconds to do one full rotation. All right, so let's divvy this up. We can say 50 divided by 4. How far apart are those tick marks? So that's 25 over 2. That's 12 and a half. Okay, so this point, do I need to know that necessarily? I don't know if I need to know that, but I could label the rest of these points. Okay, well, we have B. We have our midline, which is D. I started going off on a tangent, figuring out tick marks, but I don't think I needed to do that. We need A and we need C. Now, A is just this distance here, right? 17. So A is 17. And then what about the shift? So this sine graph that normally would start at 0 has been shifted. It's a sine curve. It's been shifted to the right 20 units. So that's going to be C is minus 20. Okay. And it's a negative sine curve. So when we write this, it doesn't, let's see, we have a model of time. Write the equation for B of t, I guess because it's Bill, the kitten. Okay, so B of t. So he is negative 17 times the sine of pi over 25 times x minus 20. And the midline was plus 29. This models Bill's height at any given time. And the question was, what was the height at 0? So the Ferris wheel did not start here. Now, you would think the Ferris wheel started on the bottom, but hey, who knows? I guess maybe when did it? Oh, whatever. We don't have to overthink it. So let's just calculate. Negative 17 times the sine of pi over 25 times x minus 20 plus 29. 41.121 feet. And, I guess what this is like, you get on a Ferris wheel and yes, you get on at the bottom, but the Ferris wheel rotates around as more people get on. And so where was Bill when it finally everyone's on and we start going? Apparently Bill was sitting at 41.121. It's a good sign that I didn't get a number higher than 46 or lower than 12 because then that might make me question where Bill came out. All right. Question my math, I should say. All right. So that's it for this problem. Come into office hours if you have any questions or if you would like to get more practice.